What if Africa could produce green hydrogen at half the cost using technology that hasn't even touched the ground just yet? So today we're unlocking the future of clean energy with two pioneers, and I'm sure you're gonna love it. So I have with me Cecilia Wandiga. She's transforming Africa energy landscape through the Center for Science and Technology Innovation, CSTI, and also have Professor Don McGlinchey, whose tech digital twin tech at Glasgow Caledonian University is slashing R&D costs. I think close to 50%, or maybe more than that. So he tell me, so I'll let you know. So what they're going to do today, it's very interesting because they will reveal to us how we can use virtual simulation, right, to simulate what it could be to run some of those systems and solving real world challenges, from electrolyzers design to the waste to hydrogen conversions. And also, they would tell us why potentially we could see Africa $2 per megawatt hydrogen dream, which could become a reality, maybe closer than what we could think, right? So we're going to dive into that. So stay with me because it's going to be a very interesting conversation. Hello, how are you doing? My name is Tony Chu. I'm the founder and CEO of Renewables in Africa. What we do is very simple. We raise awareness about renewable energy and sustainability. So if you are interested to break or expand into the continent, we are your eco-bridge to this market, and we can help you with visibility, with leads, but also deals. Or if you're looking to decarbonize, we again are your eco-bridge to sustainable pathway. We can help with carbon footprint assessment and also carbon reduction strategy. And as I said today, so I have two pioneers. They're going to talk to us about how we can make things change, how we can achieve impressive result just by using digital twin. I'm sure many of you have heard about it before, right? So I mean, I for one, I can say that heard about it, but never properly understood what do people really mean when they're talking about digital twin, and what is really the use of it? Is it just another fancy word in the era of AI, or what is it? Yeah, but I'm sure they let us know about that. So let me welcome into our virtual studio. So Cecilia and also Dan. Can you hear me well, both of you?
Yes, we can.
Excellent. I think you can. That's great. So I'm very excited to be talking to you today. I think we're going to have a pretty interesting conversation. And I just wanted to know, maybe if we start by having you properly introduce yourself, because I'm sure people watching this live will say, okay, who are they really? Right? So who is this? Yeah, who is this? So maybe Cecilia, if you start by give us a little bit of introduction, so who you are and what you do, and then after saying,
Sure. Thank you, Tony. Cecilia Wandiga, Executive Director of the Center for Science and Technology Innovation. We've been around since 1998, started by faculty who were affiliated with UNESCO, and we've retained our UNESCO association. They've been studying, including my father as one of the founders, had been studying climate change before Al Gore even declared it as a phenomenon since the 1970s. There was awareness during the 90s that Africa would experience, in the beginning, there was uncertainty that
mm-hmm.
Africa would experience the effects of climate change in the same way other areas of the world were, because we have less emissions. So then, when it was confirmed that we would, there was a need to now start downscaling scientific technology to the public to be able to help with adaptation and also eventually mitigation, which we started with crop adaptation. And now thanks to you, we're reaching out to industry and bringing out mitigation strategies.
Excellent. Thank you very much. That's very interesting. So somebody who started talking about climate change before Al Gore. Interesting.
Yes.
So Professor Don, so what about you?
Yeah, I'm a professor in the Department of Mechanical Engineering at Glasgow Caledonian. My original background was in physics. My PhD is in chemical engineering. I've spent some time in industry on a large Industries near Glasgow. Also spent a short amount of time as a consultant engineer, but most of my career has been in academia. Current research is around the issue of well, I lead a research group on digital transformation and intelligent maintenance.
Mhm.
And as part of that, we are interested in digital twinning, data analytics, machine learning, and AI. So, as part of our approach, we recognised a gap in the market for a master's programme in applied data science. If you look around, there's lots of programmes in data science, but we developed one specifically for engineers. So we have mechanical engineers, electrical engineers, computer engineers, chemical engineers, mathematicians come on the course from all over. Many from Africa actually come on the course with us. And as part of that course, we also, um, based on prior research, we do some work on digital twins for a variety of scales and applications.
Excellent. And that I want to just rebound on the last piece of word that you said there, talking digital twin. So I've heard about it so many times, and I heard that there's so many things that could be achieved, just by using the power and the potential of digital twinning. And today, I understand that you're gonna give us some clarity around that. And if I'm correct, I believe we have a presentation that you're gonna go through. So both Christine and yourself. And after this presentation, I have some set of questions that I'd like to discuss with you to make sure that we understand that properly well. So let me just move into the presentation now.
Okay.
So if that's okay, I believe that you can all see. So we can, yes, that's what you can see. So what we do is maybe if you let me know, I can obviously move the slide. So obviously that's we talk about digital twin, but yeah, I'll let you run that, and you let me know when to move to next.
Okay, if you just skip the next slide, and perhaps the next one as well, just move to the next slide. So really, this is a kind of overview of what a digital twin is, and the advantages of a digital twin. So a digital twin, as Tony has said, many people have got many different ideas about what a digital twin is. And if you look in the literature, we've found over 40 different definitions for a digital twin. So it is very much an emerging technology, and different people have different ideas exactly how you would define it. Essentially, a digital twin, though, is a virtual replica or representation of a physical object that can be an asset. For example, an air compressor or a water pump. It can be a mechanical press. It can be a chemical process that you're looking at, or it can be a system, and that system can include business systems and economics within the digital framework. In terms of renewable energy and sustainability, the sort of main advantages then of the uses for digital twin is that we can, because the digital twin is a replica or a representation of the physical world, and we monitor that physical world, we can look to optimize our resource usage, try and reduce the amount of waste that's been used, and then obviously improve energy efficiency within the asset or the system. One of the things, I'll just skip to item 4, is this idea that we can use it for maintenance purposes. So rather than wait until an asset breaks or breaks down before you fix it, the next approach would be to be condition-based monitoring, where you would monitor the condition of an asset and then schedule a maintenance intervention. We can go a bit beyond that, though, and move towards predictive maintenance, where based on the condition and some modelling, we can predict the remaining useful life of an asset. And that lets you have a much more efficient method of scheduling maintenance, and again, optimizing costs and downtime for assets or systems. Okay, maybe the next slide, please. So this tends to be the definition that we use within the course based on the Digital Twin Consortium. You can see the web link there. So the idea, it's a digital representation of some real world entity, as they say. But the key thing about digital twin is that we have data from the physical world moving into a virtual world, which is then analysed, processed, and the information from that analysis is then fed back into the physical world. So there's a virtuous loop of data and information going round and round. And that really is the key to the definition of a virtual twin as opposed to a simple simulation. Okay, so let me skip ahead now. Okay, so we just see here, an illustration of a Michelin aero engine where you have a physical system or a digital twin system. It can be something like you see there, almost a CAD type model, a virtual model, but it doesn't have to be there. It can be simply a model or simulation which mimics the behavior of the physical world on the key parameters that you're interested in. Okay, so you get at that scale for an asset. So we skip ahead. Next slide, please, Tony. So rather than, more than just a single asset, we can start to monitor entire plants, be these factory or process plants, and you can see there there's a number of air movers and compressors within that plant. And we work with one of the large industries, again based near Glasgow, who have facilities in oil and gas and water treatment and so on around the world, and they take the data from those facilities, and that's then beamed through an uplink through a slice of Microsoft Azure's and then back into Glasgow, where they analyse the data and are able to monitor the machines and then schedule maintenance based on the operations of those machines. So go from an asset level to, if you like, a factory level or a process level, and you can go one further into a business model. But the data feeds from the ground up all the way through. So the business decisions you're making are based on real world data. And that's a major advantage and a major driver for the uptake of digital twin technology. So if we move to the next slide, please. Okay, I'll let Cecilia kick in here. I'm not a chemist, and so although I know about mechanical systems and I have got, as I say, PhD from chemical engineering, I'm not a chemist, so I'll leave that detail to Cecilia. Thank you.
Thanks, Don. And I'm not a chemist either, just work with chemists who do this. So I've learned the language. So as Don was explaining, if you're looking at this from the perspective of renewable energy, what do we know already in Africa? We know bioethanol, we know biogas. We have a lot of entities and individuals who are producing home-based biogas. When you now look at a syngas system, you can now start, and you have the gasifier, the electrolyzer, you can now start separating out at a chemical level, separating out the hydrogen and generating that hydrogen. What we're looking for in terms of renewable from the perspective of CSTI is that we're looking for regenerative systems. So we don't want to, for example, look at, we'll use switchgrass or elephant grass. We want to look at, we have an abundance of waste. For those on the continent, you know that waste collection is a challenge, especially organic waste. We've got a lot of methane emissions on that, and sewage management with growing populations, urban populations. So the advantage of using a sort of bioethanol, biogas route to the production of hydrogen versus using water electrolysis is we can now start using this multi-feedstock approach and solving our waste. Now, what you don't want on the safety side is you don't want all the heavy metals, all the toxins, and all the toxic chemicals. So you need an absorbent to be removing that from the process before you get it into the electrolyzer. And what we actually will see in the next slide is we're testing a catalytic converter. And so what we want to do is co-produce biochar in this process so that it serves as that absorbent layer. And you'll see the various parts of the system that Don was mentioning. For those of you on the business side, you know that each one of these, maintaining each one of this could be a business model in and of itself. You already have what we're calling a digital twin because you have your spreadsheets, your statistics to run the efficiency, the optimization, you run stress test, you run scenario models. So now what you do is you connect that into one master system. Next slide. And like Don was saying, there's different layers, and I think we missed the slide, so let me share real quick. This is the city layer, and you can go from the terrain level, buildings, infrastructure, all the way up to running an entire city with that. Let me just see. Let me see
Oh,
if I
that's not
can.
the right. That's not the right slide.
It's not for this, but let me see if I can quickly jump in here.
Yeah, I think in that case, let me just go back to this presentation. You may want to
Yeah.
share your you share your screen if you can.
Okay.
Apologies for that.
See if
It
it.
looked like
It's okay. It's okay. It looks the same. We can. Don and I can talk forever on this topic, so we're trying to keep our.
no problem. Yeah, yeah. And it's actually pretty interesting, as I say. So I've come across a number of digital training in the past, and never
Cool.
really understood the power of it. So yeah, that's why I was actually quite keen on getting to know that a little bit more. So let me know if you have any.
It's sharing now. Can you see it?
Okay, if it's sharing, so that means I probably need to. For some reason, I don't. 1 second. It could be more on my side. That because I need to now share that on the screen.
Okay.
I'll see if I see. Do I see any? Oh, that's strange. I can't see.
If I need
Have
to
you
stop
added?
it, yes. If I need to
Okay.
stop and reshare again, I can do that.
Okay. No, no, that's fine. You're good. You're good. Here
Okay.
it is. Yes.
So this is we what we are working with Glasgow Caledonian. So we have students at GCU University, bachelor students. For those of you who are thinking you need PhDs, yes, the PhD who is our board member and chemistry faculty at GCU University designed the concept, which is one of the major cost barriers to hydrogen production is the electrolyzer, but
Hmm.
that those are also for systems that generate mass industrial scale. Um, in Africa, we don't really have mass centralized systems yet in terms of not only central aggregation of the waste, but also you'd need to transport back and forth. So, for the African context, it's increasingly likely that what we need is a management system for multiple small scale decentralized, whether it's on your farm. I don't know that this would be yet at the home level, but who knows in a future once we have this optimized on factories, and then being able to send not just the electricity data, but send
Hmm.
the business data to the utility provider or the national utility ministry, energy ministry, so that they're having real time feedback on what we're doing. We actually have, we know, and from the chemistry side, we're not talking witchcraft here. We've used the catalytic converter from a used motorcycle, and banana processing waste and pineapple processing waste, bioethanol, and we're able to convert it. We got a pop test confirmation. So chemically, it's possible. Yeah, we've done it. Now, what we have to do is answer all the questions that all of you business people, you're like, when is it going to be affordable? When are we going to get to that magic number? So that's why we're bringing in Don and his team. They've got the expertise on the simulation and the mechanical engineering, and they can start telling us, for example, we're using used equipment to start with, right? So it's very important to start analyzing predictive maintenance. Used equipment also could be more energy intensive because it's gone past its useful optimal life. So we want to make sure that during that process we're not consuming more energy. The biochar could be used to, we need to dry all this organic waste from processing has a lot of water. So we could use that biochar as an absorbent layer first, soak up the water, reduce the energy needed on the drying. So let me stop now on this before I get carried away.
Oh, thanks very much. Like I said, I've seen that, very interesting. So what definitely I'm sure we could do if later on people reach out because they want to find out more, because you have much more wider presentation on that, and then I've had the privilege to look at that, and I know some of those slides were talking about reducing prototyping costs by 20-40%. Yeah, so I was wondering, how can you explain so this tech road? So for hydrogen R&D, for example, is it the virtual lab? Is it something like that? Something else? So
Mm.
maybe Don, you want to take a turn to this question?
Yeah. Okay. So, whether it's this particular uh, adventure or other uh, prototype you're looking at, the the role of a digital twin can come in right at the conceptual stage. So you can make some models just based on concepts, try them out, see if they work okay. But you can take it a bit further than that and get to what you might call front end engineering design. So a wee bit past concept. And then you're starting to look at developing prototypes. So you're selecting equipment, you're putting that together and so on. And if you can do some of that work virtually in the virtual space, then it's going to reduce your prototyping costs. So immediately you're not having to buy equipment, try it out. Oh, that doesn't work, I'll buy something else. You can try various scenarios within a virtual world and see how that works. So reduce your prototyping costs.
Mm-hmm.
Once you have that virtual prototype up, you can then start to make some tests. How do you optimize a prototype, or how do you make best use of a prototype? So again, you're speeding up and you're reducing the number of physical tests you have to do. Once you have that idea and you're fairly confident that you have a system that's viable and workable, you're then in a position to take that to market in a much faster time than you would if you went through a traditional route of having to do physical build, physical adaptation, and so on. Another big factor that's useful from a business perspective is risk mitigation as well. Because everything's in the digital space, you can start to look at flaws in the design or things that aren't optimized, and then make changes there, which is obviously much cheaper to make in a digital space than in a physical space. So that certainly all helps move that concept through a digital route into marketable viable product.
Excellent. That's very, very interesting. Thank you for your detailed explanation there. So I've read, Cecilia, that the CSTI is targeting achieving $2 per megawatt, which is obviously quite huge for hydrogen. Obviously, we're talking about now. R&D, we know it's pretty expensive, right? It could be pretty expensive, and the whole idea, like Professor was just explaining just right now, of digital twin is to bring those costs down. Now, to be a bit more factual, because obviously, as we know, so if you have somebody, people come from private sector, just I do, they want to know specifically which one are we talking about. Is it the electrolyzer design, which we know could be pretty expensive, maybe the most expensive part at the moment, feedstock, scaling productions. So, which one digital twinning will help slashing?
So the answer and the reason it gets complicated is everything. So we're using this new approach to investing called systemic investing. Not that I knew it, but I learned through finance people the other day. We're just as finance is learning environmental science, we're learning science. So the idea is we'll have to simulate feedstock. So how much capacity will it take to generate 1 megawatt of hydrogen? Okay, we're using this approach. Once we have that, we also then need to say sustainability of that feedstock. One of the reasons we're looking at agricultural processing waste and sewage waste is we already know the production levels of those feedstocks because we have the agricultural data. Which is very different from trying to say, let's grow some kind of new trees or something for like, I know some people are using Prosopis julifera, but then you have to start simulating what that growth cycle is and all that. If you base it on the systems that you already have, you now have that part of the business model solved and you're plugging it in. The electrolyzer we're saving because just simple common sense of not having to import equipment and train people on how to use the equipment. You already have mechanics who know how to fix motorcycles. So we have the in-house expertise in the ecosystem on fixing motorcycles, So now it's how to repurpose that expertise to a new skill. And that training and conversion, that's the part that we don't know. How long does it take to train somebody to do that? To train them, instead of reducing motorcycle exhaust, you're now making hydrogen. The other part that we need to then simulate is the chemical reactions and what starts happening at a larger scale in terms of climate emissions and modeling and does it and behavioral, because a lot of times we expect people to, if we do A, they'll do B and they do Z.
Completely different, right?
Completely different and unexpected. So we need to start testing all those parts. And the most important part, I think, that we're learning to empathize with entrepreneurs is, especially when you get into sort of large scale investors, is you come in and you present the model and you've answered all their questions. And as you're presenting, it's almost like a PhD defense where they ask a whole new set of questions again, and you need to retool the model all over again, because as they're seeing something new. And that part becomes a lot more cost effective than if we were doing multiple physical simulations.
I think that's pretty clear to me. So when we looked at the presentation, I think it was last page or one of the last pages, we talked about the purification of syngas. So, Dan, so how can these digital twins simulate the waste in African context, right? Where we have, for example, waste in biomass feedstock, in order to predict the yield for those physical plants.
Yeah. So, essentially, if you can develop a simulation or a mathematical model of the behavior, of whatever it is. So you may be drying, grinding, preparing the waste. You may be um, putting it through some chemical process, as long as the reaction chemistry is known and can be modelled. All of this can be built into the digital twin. Um, scale up, scale up is always tricky. Even from what you think might be a simple system. Um, I've also got a background in particulate materials and granular mechanics and that sort of thing, particle technology, and that presents real physical challenges. There are ways to simulate that through discrete element methods and so on, Eulerian methods and whatnot, but it does get a bit tricky. So, as I say, I can't speak to the chemistry, but I've done enough simulation in various uh, applications that I know that if we can have the models there, we can join them together and then develop a behavioral model for the system that we can then tweak and optimize for whether that's energy output, um, biochar output, or whatever the target would be for the optimization.
Okay. So thank you for that. I appreciate it. So for African made electrolyzer, so Cecilia, so how can you what do you what do you think about digital twins helping smaller factory to compete with global player? So is it something we can clearly expect could happen, or is just purely a dream?
I think it's something we can expect that could happen. Now, doing it on a mobile phone would be challenging. You definitely would need some type of PC, just to put that in context. But once you have that, you have laptops now that have sort of desktop replacement computing power. You can enhance your computing power with cloud-based integration. So in terms of capability, have internet, you can have a modeling system.
Correct.
Where I think then it would be a really good innovation system is to have intermediaries like Glasgow Caledonian University who are not only technically proficient, but they have no sort of profit incentive to stop us from innovating. They're on the discovery journey along with us and have sort of a network of innovators who have set up their digital twin model. And we have some certain parameters, not like a hackathon, but like a designathon,
I
where
like the name. Designathon.
we give sort of the design constraints, and everybody is sort of feeding into that system and showing here's what I did, here's what I did. And that's kind of the African way of innovation anyway. We don't,
Correct.
yeah, exactly. So I think
Now,
I think there's a lot of potential.
great. And a lot of because obviously we talked about new technology here, so hydrogen,
Mhm.
and then but it could be applied obviously to many other technology as you mentioned, so R&D in general.
Mhm.
That's where we see the potential strength of digital twinning. The other thing as well, which I find interesting and is pretty much represented here in this conversation well, is collaboration, right? Because what we have in here, it's Dan represent here obviously the Scottish expertise from the Glasgow Caledonian University, and you obviously Cecilia, the CSTI, so the African, the Kenyan expertise here coming together. I was wondering whether you can talk about how this collaboration has been beneficial to this topic in particular, but also more broadly. And maybe if you can share some of the concrete win that you've been able to engineer by just coming together. Any
So
of you, actually.
I'll start and then hand over to Don. And Don, when you pick up, also, not everybody might be aware of the importance of Glasgow in the global climate debate. So if you could also enlighten on that. So in our sense, we started about a year ago with this idea of, and it was a mandate from State Department of Public Works here in Kenya, to start decarbonizing the construction sector and looking at a material that would cross all pathways. So we're looking specifically at cement. Of course, you can use biochar to and hydrogen to decarbonize steel as well. We're not yet into the steel. We're looking at the cement.
Mhm.
And so we started bringing different players together, community-based organizations who are on the wildlife side, individual architects, engineers, SMEs, some global, some local, and all having their different types of ideas, and also the Concept Technopolis Authority. We have a research collaboration with them, and they're creating Africa's first smart city. So, in trying to manage all those ideas and all those prompts, everything from constructed wetlands to 3D printed buildings, Don said, I think we're going to go crazy if we don't start putting this into a digital twin system. And so the same presentation that we're sharing with you, we've shared it internally with the team, and it's the end result of about a year's worth of discussion of where everybody wants to contribute in terms of their particular strength. We didn't mention biodiversity monitoring, but that's also a key area that people want to monitor. And now we've released that, and they're now starting to respond. For example, there's a company called iCrete. They have a concrete maturity index. They're experimenting with solar miniature solar panels to um, at, use the constant energy for their temperature concrete sensors. But what happens then if they're also using sort of an on-site hydrogen generator in that concrete mix? So and seeing what a local, what we call fundi, a local mechanic, can do in terms of in a factory, and simulating as much of that as possible. So that's probably, we'll get there in about 4 or 5 years, but we're just starting by putting their pieces of the innovation system together and learning together how to build these digital twins.
Excellent, brilliant. So Dan, I think you want Cecilia wanted you as well to add a little bit
Yeah,
of
yeah.
insight there.
One of the main mission of Caledonian University is to be a university for the common good, as we say. In Scotland, we say the common weal. It's a Scottish word, WEAL, which is a bit more than just well. It's kind of well-being, or to benefit society and so on. So as part of that, we are very interested in sustainability and climate change. We host the Mary Robertson Centre for Climate Justice, looking at the effects on climate change on various communities around the world. Um, that's much more a policy based rather than a technology based. Our own research is more focused on, my personal research is more focused on the technology aspects. But when we started having original conversation with Cecilia and some of the group through there, I get really interested in this idea of how we could contextualize the technology in different places. So it wasn't simply, oh, we've got one that works, so we can just copy paste and put that everywhere. And it's how we contextualize that both within the available technologies, but also within uh, local cultures and societies, and how those societies can also, one of the good things about digital twins is it can also take in um, user experience, human experience. So we can get feedback from society, the users, the operators, people who live in the area. All of that comes back to the digital twin and gives information on how the things operate, how things work, and how it can be developed over time. So all of that I found really exciting, and I was really glad to start to collaborate with Cecilia and her friends over there.
And we're very pleased to see this kind of collaboration because we strongly believe that that's the way forward, even in the industry, private sector. I think usually you see some of the major breakthrough when you have resources coming together, people coming and bringing their own expertise, the insight, the intelligence, looking at the same problem but from a different angle. This is where you're able to come up with very new idea that have not been exploited before. I have one last question. I think I love to speak with you for another 40 minutes, 2 hours, because the topic is so interesting. Maybe we can have follow up to this conversation. But one last question, and I was hoping that you could actually enlighten me on that. Because at times we do get as well some official from the continent. So watching our expert interview, because we always bring to the platform, like I say, people on the top of the game, so that help us to figure out so what's the way forwards. So African governments, because I think we like to see them a lot more involved as well in R&D, right? Not just being consumer, but be clear in the market. So let's imagine an African government is allocated to $1 million for hydrogen R&D, because at the moment there's a lot of buzz on hydrogen. So what do you think they should spend it on? On physical lab or digital twin infrastructure? Just pick one. What would it be?
So if I had to pick one, I would say the digital twin because of our lack of data across the continent. The caveat being that the digital twin depends on the physical twin, but that's a whole.
No,
But
you
if you
can't go
had,
for you can't go for a political answer. It has to be one.
I would say start with the digital. Start with the digital and see how much it forces us to figure out how much data we actually have and where the data gaps are. Yeah.
Yeah. Would you say the same, Dan?
Um, yeah, with the same caveat, obviously a digital twin needs a physical twin. But the whole thing about the digital twin is it's not, the way we look at it, it's not tied to a specific application. So once you understand the concepts, the technology, and how that's put together, you can then start to move or develop digital twins in any space you like, whether that's manufacturing, whether it's agriculture, whether it's business. So once you have developed the process, the roadmap, if you like, for one application, you're then in a much better position to take that same roadmap and develop it for a new, perhaps an innovation no one's even thought of yet. So yes, I am biased, of course, but I would say I would start with digital twin.
I think you're way too smart for me, because what I didn't take into account is the fact that you can't be a twin if you don't have the other set of twins, which is the physical. That's very good, very good. So on these very kind words, so thank you very much for obviously your kind insight. So you've taken us through this concept of digital twinning, how we can really enhance R&D globally, but also more specific in the African continent, and also looking at the questions that we talk about these days, like hydrogen. We don't even talk about AI. We didn't have time for that. Definitely will want to explore that later on. But it was very, very insightful, very interesting to get to know a little bit more about that and see what is really the potential. So I just want to thank you both for your availability, and then and for coming down on our platform to sharing that with our audience. So thank you very much, and I wish you an excellent rest of your day.
Thank you
Thank
very
you
much
so
for
much.
inviting us to the conversation, Tony.
Thank you. Thank you very much for that. I appreciate that. So it means that it looks like I might need to find out a digital twin for myself, right? So we'll continue the conversation over and over again. So maybe this way we can have 24/7 conversation. So more seriously, a massive thank you to you, Cecilia, and also Don, for showing us how the marriage of African ingenuity and cutting edge technology can rewrite the road of clean energy. And one thing is very clear to me, and is the fact that the future of hydrogen and other technology isn't just about the physics. It's also about the phygital, if I could say that this way, right? Where you marry the physic, physical plus digital innovation to bring them together. this is how you actually build a twin, as we were talking about. So our viewers, I just want to geek out on the data and to say that make sure that you check definitely what CSTI is doing, the project that they're running, and also looking at Caledonian University. Obviously, they've been very kind to the GCU to share a bit about their research, through Professor Dunn. And then, and if you believe in solution before infrastructure, definitely, hit the thumbs up, the comments, to tag someone that you know to see that. And until next time, so stay curious and stay bold. And thank you very much for watching us. Bye-bye.